Okay, today we will learn about IDS. This is our module flow, IDS, firewall, and honeypot concept. Second, we learn IDS, firewall, and honeypot system. 3, evading IDS. 4, evading firewall. 5, detecting honeypot. 6, firewall evading tool. And 7, countermeasure. And lastly, penetration testing. To understand IDS, firewall, and honeypot, evasion technique is used by the attacker to break into the target network or system. It is necessary to understand this mechanism and how they prevent intrusion and offer protection. So let us begin with basic IDS, firewall, and honeypot concept. Intrusion detection system and their placement. Here you can see all the traffic must come from the internet and go through router and detect by the IDS. Here we also use DMZ, or we call delimitary zone, and then we connected with another IDS before the traffic go through to the intranet. Here intranet is our local network connection. An intrusion detection system gather and analyze information from within computer or network to identify the possible violation of security policy, including unauthorized access as well as misuse. And IDS is also referred to as a packet sniffer, which intercept packet traveling along various communication medium and protocol, usually TCP, IP. The packet are analyzed after they are captured. The IDS filter traffic for signature that match intrusion and signal an alarm when the match is found. Intrusion detection system is used to monitor and protect network or system for malicious activity. To alert security personnel about intrusion, intrusion detection systems are highly useful. IDS are used to monitor network traffic, and IDS check for suspicious activity is notify the administrator about intrusion immediately. An intrusion detection system gather and analyze information from within a computer or network to identify the possible violation. IDS refer to packet sniffer, which intercept packet traveling along various communication medium and protocol. Here is sample of the IDS placement. How IDS work. Here you can see there are 3 parts, which is from the traffic coming from the internet, and then through the firewall and IDS. In IDS, we have IDS processor, where IDS, they have two technique, which is signature, anomaly, and lastly, stateful protocol analysis. In signature comparison, anom if anomaly is matched and we see go to the match with the database, it will go to the response either to alarm notified admin or cut down from the IP source or packet is dropped. If signature is not matched, and we go through the anomaly detection. Anomaly detection detect based on behavior or their activity. If matched activity, we will go to the connection is cut or packet is dropped or alarm to the security administrator. If not matched, we will go to the stateful protocol analyze. In protocol analyze, we test based on the protocol network. Okay. Then if it not matched, that means the packet is benign or non-malicious. So we'll go through the enterprise network, or we call LAN, local area network. Okay, here IDS, the main purpose of IDS to not only to prevent intrusion, but also to alert administrator immediately when the attack is going on. The administrator could identify method and technique being used by the intruder and also source of attack. IDS work in the following way. IDS have sensor to detect signature, and some advanced IDS have behavioral activity detection to determine malicious behavior. Even if signature do not match this activity, detection system can alert administrator about possible attack. If the signature match, then it moves to the next step, or the connection are cut down from the IP source. The packet is dropped and the alarm notify the admin and the packet can be dropped. Once the signature is matched, then sensor pass on anomaly detection whether the received packet or request match or not. If packet pass the anomaly stage, then stateful analysis is done. After that through, switch the packet pass on the network. If anything mismatched again, the connection are cut down from that IP source. The packet is dropped and the alarm notify the admin and packet can be dropped. Way to detect an intrusion. It also known as misuse detection. Signature recognition try to identify event that misuse a system. It detect an intrusion based on the fixed behavioral characteristic or the user and component in a computer system. In this type of detection, models are built to explore anomaly in the way vendor deploy the TCP IP specification. Signature. A simplest form of signature recognition use simple pattern matching to compare the network packet against binary signature of non-attack. A binary signature may be defined for a specific portion of the packet, such as the TCP flag. Signature recognition can detect non-attack, however, there is a possibility that other packet that match might represent the signature, triggering bogus signal. Signature can be customized so that the well-informed user can create them. Signatures that are formed improperly may trigger bogus signal. In order to detect misuse, the number of signatures required is huge. The more the signature, the more attack. The bandwidth of a network consumed with the increase in the signature database as the signature are compared against those in database, there is probability that the maximum number of comparison cannot be met, resulting in certain packet being dropped. Anomaly detection. Anomaly detection is otherwise called not use detection. It's different from the signature model. The model consists of database of anomaly. Any event that is identified with the database is considered an anomaly. Any deviation from normal use is labeled an attack. In the traditional method of anomaly detection, important data is kept for checking variation in network traffic for the model. However, in reality, there is less variation in network traffic and too many statistical variation, making this model imprecise. Some even labeled as anomaly might only be irregularity in network usage. In this type of approach, the inability to instruct model truly on the normal network of the grave concern. This model should be trained on a specific network that is to be policy. Protocol anomaly detection. Protocol anomaly detection is based on anomaly specific to a protocol. This model integrates into IDS model recently. It identifies TCP/IP protocol, specify flaw in the network. Protocols are created with specification non-RFC for detecting proper use and communication. There are new attack methods and exploit that violate protocol standard being discovered frequently. The packet at which the malicious signature the attacker is growing is incredibly fast, but the network protocol, in comparison, is well defined and charging slowly. Therefore, the signature database must be updated frequently to detect attack. Protocol anomaly detection systems are easier to use because they require no signature update.